So today we are doing 9.1. We are starting a new unit, and our next two units are going to be on rational functions, which rational is just a fancy word for a fraction. So we have 3 sections in this unit, and today we're going to be talking about inverse variation. You guys did direct variation in Algebra 1. So we're going to review that first, and then we'll go into inverse variation. I just remembered my pen. It's not working well. All right. So let's say that we have a scenario where we have a rectangle, and I'm telling you that the width has to stay constant at 2. Let's choose some lengths and then calculate the areas that would go with it. So I'm just going to choose some small lengths like 1, 2, 3, 4, 5. All right, then find a pen that will be dark enough for you guys to see. So if my length is 1 and my width is 2, what would be the area of this rectangle? Yeah, we would just multiply them together. So this would be 2, and then 2 times 2 is 4, and so on. We would multiply them together to get 6 and 8 and 10. Man, I'm not having luck with pens today. All right, so let's go ahead and graph this. This should look familiar from Algebra 1. If my x-axis is length and my y is area, the shape of this graph should look familiar. You studied a ton of this function in Algebra 1, this linear function, right? Anytime it's a straight line. And so a direct variation relationship means that as x increases, y will also increase. That's a direct relationship. The variables move in the same direction. Also, it could be the other way around, right? As x decreases, y will also decrease. That would be a linear equation that is sloping down this way. So those are called direct variation. And whenever you have a direct variation, you always have a constant value. We call it K. Why they don't use C, I don't know. It kind of drives me crazy. But C is the letter that you see in all the textbooks that they use for some reason. So our constant in this scenario was the width of 2. That was our constant. Every time we calculated the area, we multiplied it by that constant 2 of width. And if we wanted to find out what this constant was, we could always divide every area and it would give us the length. So we would divide 2 divided by 2 to get 1, 4 divided by 2 and 2, 2. So if we wanted to figure out what that constant was, we could divide to figure it out. So an equation to represent this scenario is we could calculate the area by taking the constant 2 and multiplying it times that length, 2 times the length. So this is a direct variation. You do the constant times the x value, whatever it is, and in this case, it's length. So this is an example of a direct variation. Now let's compare it to what we do in Algebra 2. We do an inverse variation. So how I'm going to change the scenario a little bit is this time I'm going to tell you that you need to hold area constant. So I'm telling you the area of this rectangle is always going to be 12 inches squared. I'm going to give you some lengths, 1, 2, 3, 4, 6, and 12. So knowing if my length is 1 and my area has to be 12, what does that make my width? What would I have to keep that at?
12.
Yeah, it would be 12 because we know that these have to multiply together to get this constant of 12. And again, this one would be 6, 4, 3, 2, and 1. So think about to yourself what you think this graph will look like. We had a linear function here. I wonder what the graph will look like for this one. So go ahead and graph these points. Your x is going to be length. Your width is going to be the y. And I realize we're a little bit off the graph for the 12s, but you can kind of estimate where it would fall. Is that graph a little different than what you had imagined? A lot of my students are surprised when they see it's a totally different graph. And this is kind of the beginning of our new function that we're going to be studying. We're going to be studying a rational function. And this is actually only one piece of the rational function. Because this is a real world scenario, we can only see the first quadrant. There's actually another piece down here that we're going to study next time in 9.2. But the reason we're getting this curved graph is because the more we increase the length, the width has to go down. The variables are moving in opposite directions. However, keep in mind, we can never have a negative width and a negative length. So this is going to get closer and closer and closer to the x-axis, but we will never have a zero width because then it would no longer be a rectangle, right? It would just be a line. So on both sides, it's going to get closer and closer to the axis, but it will never touch it. And we're going to be talking about that more next time. Those are what is called an asymptote, a line that the graph approaches but never quite reaches. So in this scenario, our constant is 12. What we held constant was the area. When you multiply these together, you will always get that 12. When you multiply the length and width together, the x and y's, that's when you're getting the constant value. So our equation this time would be a little bit different. Let's say I'm solving for the width, the y value, because that's what we usually set it equal to. If I was going to write this equation, this time I would take the area of 12 and I would divide it by the length to be able to calculate the width. So this equation, when we see inverse variation relationships, you will take the constant and divide by the x value to find the y value. So that's the relationship. This time, every time x increases, y will decrease, and as x decreases, y increases. So on inverse, by the way, inverse and indirect, you can use those words interchangeably. I've seen them both used in textbooks, and I don't know why, but they're very similar words, but they mean the same thing, indirect and inverse. So the variables always move in opposite directions from one another. Okay, so now that we have the foundation, let's practice some scenarios. So whenever you see this sentence, y varies inversely with x, this tells you this is going to be your first variable. And when it tells you it varies inversely, that means you're always going to have this setup that it's going to be divided by, you're going to have your constant divided by x. It will always be this setup for, they're telling you what the relationship is between the x and the y values. Once we know this, we can plug in the information they gave us. So if x equals 35 and y equals 90, I'm going to plug in 35 and 90. So once you know this relationship, you can always multiply your x and y coordinates together, and it will give you the constant. So I can multiply these two together to find k, which is 3,150 if I multiply those together. So now I know my constant. Once you know the constant, you have an equation that you can use to solve for any question that they throw at you. So this time they're asking us to find y when x is 50. So we just plug in 50 for x. And we will know what y is. So that goes in 63 times. So every time your first goal is to figure out what that constant is, because then you can answer whatever question that they're throwing at you. So let's read a scenario now. Look at number 2. Kim lives in the suburb and drives to work in a city. The time it takes her to get to work varies inversely with her speed. Okay, so this is what I want you to do. So underline time. That's going to be the first variable they give you is always going to be like your y. That word varies inversely means that we're going to have a constant divided by whatever variable they're about to give me with driving speed, s. So that first sentence kind of sets up what the relationship is so that you can set up your equation. So when she averages 20 miles per hour, so that's a speed. I'm plugging 20 in for the S. It takes her 1.5 hours, that's a time, to get to work. How long would it take the trip if her average driving speed is 50? So remember, our first job is to figure out what the constant is. So I'm going to multiply these two together. So 1.5 times 20 is 30. So now we have an equation that we can work with. Time equals 30 over S. So that's the equation we can use to solve whatever they ask us. So they are asking us, how long would it take the trip if her average driving speed is 50? So I'm going to plug in 50 for a speed. Since it's 50 miles per hour, that's a speed. So this was given us into hours because this was miles per hour and the time was also in hours. So this is, my answer is 3/5 of an hour. But let's translate it to be something that's like how we usually talk, since I usually don't say, hey, I'll be there in 3/5 of an hour. Let's put it in some minutes so it makes the answer makes a little bit more sense. You know how to convert it into minutes? You guys have any thoughts? So if this is 3/5 of an hour, okay, and we know that there's 60 minutes in an hour. So what I can do is I can multiply this times 60 and it will convert it into minutes. So if we want to multiply this, it looks easier. Instead of multiplying straight across, I'm going to divide by 5 first so that I get smaller numbers. So 60 divided by 5 is 12. And then I'm going to multiply times the 3.
36.
Yeah. So 36 minutes is how long it would take her if she was driving 50 miles per hour. So that's how you can convert it. If you're left with hours, just always multiply it times 60 and you will be able to convert it into minutes. Okay, example number 3. Questions so far? How are we doing out there? Are y'all following along?
No questions.
All right. Let's try, number 3 is one that's got a direct relationship. So let's try that one. So remember, first variable is going to be your Y. So the bending of a beam, I'm going to call that B, varies directly. So when it says directly, this means instead of it being divided, it's going to be a multiplication problem. So my constant is going to be multiplied times the mass. So the direct relationship we're going to set up that way. All right, so a beam is bent 20 millimeters. So that's the B by a mass of 40. So that's the mass. So how could I solve for the K to figure out what the constant is on this one?
Divide it by 40.
Yeah, that will work. I can divide by 40. So 20 divided by 40 would be a half or 0.5, however you want to write it. I guess I'll do 0.5. So now we know the relationship. The beam, the bending of the beam is going to equal 0.5 times whatever mass we are given. How much will the beam bend with a mass of 100 kilograms? So they gave us a mass. I'm going to plug that in for M here. So B equals 0.5 times 100. So I get 50 millimeters would be the bending of the beam. So those are our 2 scenarios, and I will let you work through. If you would like to, a couple more examples, you can do 4 and 5 for inverse, but I would like to skip down and talk about the table and graph as our last things for today. This table gives the amount in dollars that each person owes when a group of people buy a birthday present for a friend. So the more people that help buy the present, the less each person will have to contribute, right? This is going to be an inverse relationship. How much does each person owe when 8 people chip in for the present? Before I get into that, a more important question about this table is, how do you know if it's an inverse relationship when you're looking at a table? So a lot of my students say, well, as X increases, Y decreases, which is true, but there's more to it than that, because that's not enough to prove that it's an inverse variation. What is most important is that they have a constant. If they have a constant, this K, if we can prove this K value, then we have proven that they're an inverse relationship. So let's multiply all these together and see if they're an inverse relationship. So 2 times 40 is 80, 4 times 20 is 80, and 5 times 16 is also 80. So now we have proven that they are actually inverses of each other, because when I multiplied all these together, I always got this constant of 80. So this is what actually proves that they're inverses. I'm teaching online. I know it looks like I'm talking to myself.
Whatever works for you.
All right, so it's always funny when I'm just talking to my computer and everybody's like, who are you talking to? There's kids out there. All right, so we have a constant, so we know this is an inverse relationship. So that also tells us how much the present was. The present must be $80. So the more people that contribute, the less it's going to cost. So let's see, if 8 people chip in, that means that each person will chip in $10 for the gift. So the question is really easy, but I wanted to make sure and talk about, if it asks, I think it asks the question on your homework, how do you know this is an inverse relationship? Go ahead and multiply all the information they give you just to double check that it is an inverse relationship. Because if it doesn't, then you have proven it's not an inverse relationship. All right, same with looking at a graph. If you need to figure out what that constant is, you can multiply your X and Y together to figure out what that constant is. So if I multiply these together, I think I get 14,000, yeah. So you can figure out your constant, and then once you have an X or a Y value, you're able to figure out we could figure out any value on this graph if we have an X or Y once you get that constant. And that's it for this lesson. So mostly it's just practicing setting up the equations and then solving for that missing piece of information. This one is usually a fairly easy lesson in Unit 9. But is there anything I can help clarify for you guys?
So most of the problems are going to be inverse, right?
Yes, most of them will be inverse. That is our focus for Algebra 2. Algebra 1, we do direct. I think there's like 1 or 2 direct ones on there, just so you're used to seeing them, because I know they're on the SAT test and I wanted you guys to be familiar with them. But our focus for this class is going to be the indirect.
Okay.
Thank you.
Kat, did you have a question?
No, ma'am, I got it.
All right, very good. Well, you guys finish up your homework. Your homework is fairly short on this lesson, and do your progress check. And I will see you again on Monday for 9.2 for our next lesson. And we will see you then.
Bye. Have a great day.
Bye.